Good afternoon, everyone. Welcome to 5.2 in Calculus. This episode is on area. In the end of this, you guys should be able to use sigma notation to write and evaluate a sum. Understand the concept of area itself. That's area under a curve. Approximate the area of a plane region and find the area of a plane region using limits. All right. Stuff that you have covered before in pre-calculus, but we're going to cover again. You ready? A little long, but if you take your time going through it, it's easy. So what we're going to start with here is very simple. We are going to start with just going over what a couple things are. I want you guys to, though, do the do now problem on the test you guys just took to make sure you remember what you do, because you have to remember how to pretty much integrate to do this stuff. So let's go. All right, let's see what you guys got. First thing you should have done there is you should have reduced, dividing both of those by the denominator, which is x to the fourth. 7 minus 4 is indeed 3, so you got 8x to the third. 1 minus 4 is a negative 3, so you get 6x to the negative third. Now you're going to integrate these using your power rule. In case you guys forgot what the power rule is you take this number, you add 1 to it, and then you divide by that same number. So, first thing you do is you separate it, you take out the coefficients. 3 plus 1 is 4, divided by 4. Negative 3 plus 1 is negative 2, divided by negative 2. And then you distribute. 8 divided by 4 is 2, 6 divided by negative 2 is negative 3, and you get your answer. Easy. Try this one. Actually easier, you're just using a little trig function. All right, so if you also want to write this as x to the negative 2, you can put it 3 divided by x squared. All right, you can always rewrite it. Either way is correct. This one right here, you take out the 4 and take out the 9. 5 plus 1 is 6, right? And the integral of secant squared x dx is tan x. So this just becomes a tan. So 4 times x to the 6 over 6 minus 9 tan x. All right, 4 over 6. Divide both by 2 becomes 2/3. 2/3 x to the 6 minus 9 tan x plus c. And that's all there is to it. Okay, so just because we took a test on something doesn't mean you should forget it. You should always just keep on learning, remembering, refreshing your mind. All right, and finals are coming up soon anyway. Yes, it finals. Sigma notation. So this is what we're going to get into. This is the main part of the lessons we're going to be doing. So if you can't get this stuff, it's going to be difficult. I'm going to take you up in general levels. I'm going to start you at the basics and then build you up. So first thing, you have to know what the sigma notation form looks like. This is the sum of n terms. N is the number on top of the sigma. That's just the Greek letter. When you guys go to college, you'll probably know that if you go to fraternities or sororities, in terms of A1, A2, A3, all the way to A to the n. So these are all different things you're going to add, find the sum of, until you get to the nth term. So for instance, this has 4, this has 6, all right? This is how it's written. I equals 1, and then we got n over a to the subinterval I. So this a subinterval I, that is going to equal a1, because that's your first term, second term, third term, fourth, fifth, all the way till you get to the nth term. All right, so if this number is 10, you'd have 10 of these terms you're adding together. 4, you'd add 4 together, and so on, okay? Sometimes it starts at 0, but in this case, it's starting at 1. And what exactly is a to the I? A to the I is the ith term of the sum, okay? So that means it's either the first term, the second term, the third term. So you're taking the function and you're plugging in numbers. You're plugging in a 1, a 2, a 3, a 4, stuff like that. I. Here, why don't you say, what do you think it is? It's the index of summation. Okay, index of summation is where you're going to start at, what term you're going to start at. You don't always have to start at 1, but most of the time, when we're doing this later on, we're going to start at 1. N is the upper bound. That means that's the number that you end at. Now 1 here, in this case, I could have called it a letter, is not the upper, but the lower bounds. Okay? So upper bounds is the last number you're going to use, last term for A you're going to use, and lower is the first term. So look at this problem right here. See if you can do 3 on your own. If you can, wonderful. If you remember. If you can't, I will explain it to you. Right? So I'm going to write this not as the formula yet, just as writing it out to show you how long it takes to do this a long way. So this 2 is where you're going to start at the 1. So 2x would be 2 times 1, right? And then we're going to stop at 4. So you got 2 times 1. Now what number comes after 1? 2 plus 2 times 2, because it's sum, so you're adding plus 2 times 3 plus 2 times 4 plus, we stopped. Remember, we said we're going to stop at 4. So you're just going whole numbers up till you get to your starting one, add them all up, add 1 to all of them till you get to the stop point. And then what you do is you simplify. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. All right, and then you add them. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. See, not too bad, right? Tedious to do it this way, but I'm going to show you a quicker way to do it in a little bit, but I want you guys to get the concept first. So, attempt number 4. Let's see what you got. 1 plus 2 plus 3 plus 4 plus 5, all the way to 6. Add the numbers together. 3, 6, 10, 15, 21. All right? All you're doing is adding. If you can add, good. If you can plug things in, good. All right, let's move on. I want you guys to try examples 5 through 9. All right, let's see what you got. First example here. You're going to start here. We start with a 2. The lower sum, the lower bounds have changed. And also you got to make sure whatever letter this is equal to is the one that you're filling in. I, J, K, all right, I. So if there's different letters involved, you're just filling in the letter that is with your lower bound. So we're going to go from 2, 3, 4, 5, 6. You should add them all together and got 20. This one you start with the 0. So 0 plus 1 plus 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, plus all the way to 5 plus 1. All right, and you don't have to write this all out if you don't want. But this is 1, 2, 3, 4, 5, and 6. You're adding them all together. And as an answer, we did before, 21. Pretty easy, right? I think so. You think so too. Ooh, now we got j squared. So we're starting at 3. So you start with 3 squared, 4 squared, 5 squared, 6 squared, and a 7 squared. So you got a 9, 16, 25, 36, and 49. Add them together because you're squaring each term individually. You don't add them all up and then square them. You have to treat each one as its own function, and you get 135. All right, not too bad. This one gets a little some people. Now 8 and 9 are a little tricky, but not too bad. 1 over n, and then you have a k equals 1. What that means is you don't do anything with the 1 over n. It stays 1 over n. You're just plugging things in for the k. So this is 1 over n times 1 squared plus 1, right? 1 over n times 1 squared is 1 plus 1 is 2. All right, so that's your first term. And now we're going all the way up to 6. So you're going to add all this other stuff. 1 over n, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1, 5 squared plus 1, 6 squared plus 1. So this becomes 4 plus 1 is 5, 9 plus 1 is 10, 16 plus 1 is 17, 25 is plus 1 is 26, and 36 plus 1 is 37. Now, because these all have 1 plus n in front, right, you can add up all these terms because they're the same variable. And you get 1 over n times 97 or 97 over n. Another way to do this so you wouldn't have to write all this out is you could just save the 1 plus n to the end and just do these pieces. Get these numbers, add them together, they get 97, and then multiply it by 1 plus n at the end. It's up to you. Whatever floats your boat, get the same answer. Another tricky one here. You guys know how this one works? Now, n means it's really unbounded. I mean, we don't know what n is, so you just create an equation here. So this would be f of x1 plus f of x2 plus f of x3, and they're all delta x's, dot, 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 all the way to f of x to the n, delta x. And you don't have to put these middle pieces in here. But what you know is this is more of an infinite sum. We're not really getting into it. It's just showing you that you always don't have cut and dry. All right? That was a trick one. I know I got you. But now you know. It's always good to trick you. You remember better. All right. Why don't you go to 10 problems 10 through 15. You did it already? Awesome. Plug in your 1. 3 times 1 plus 2. 3 times 2 plus 2. All the way into the end. This becomes 3 plus 2 is 5. 6 plus 2 is 8. 9 plus 2 is 14. 12 plus 2 is 14. Oh, that's 11. 15 plus 2 is 17. And 18 plus 2 is 20. Add them together, you get 75. All right, 11. This is kind of a double, but good thing we start at 5. So it's 5 times 5 minus 4. 6 times 6 minus 4 is 7. 7 minus 4. And now remember your rules. In parentheses first, Pam does, parentheses first, right? This becomes a 1, a 2, 3, and a 4. So 5 times 1 is 5, 6 times 2 is 12, 7 times 3 is 21, and 8 times 4 is 32. Add them together to get 70. All right? And most of you guys probably don't need me saying what to do each term, but if it helps one or two of you, that's right, I'm explaining everything step by step. I could probably just put the answers up here and you guys would be happy, but why even do it then, right? All right, here we're going to go from 5 to 8. 1 over 5 squared plus 1, 1 over 6 squared plus 1, all the way to 1 over 8 squared plus 1. 5 squared is 25, plus 1 is 26, 37, 50, and 65. Calculator work, you get some decimal. 0.1008. I rounded to the 4th place just because that's how many spaces I have. 10, 100, that's like the 10,000ths. So this would be 1008 10,000ths. Make sure the TH is there, else 10,000. All right, so 13. We go from 4 to 7, 2 over 4, 2 over 5, 2 over 6, 2 over 7. Calculator. If you want to reduce this to 1/2, you can. I don't know why. If you want to add these up, you can find the common term, which is 270, right? Because 2 times 5 times 3 times 70 is, sorry, 210. I don't know why I said 270. So this would be, let's see, 105 over 210, a big number over 210, 70 over 210, and 60 over 210. You add them all together, you get 319. Or you can just use a fraction. That's what I would do, easier. 1.5193, right? And the reason I got 210 is this would have to be multiplied by 105 over 105. This would have to be multiplied by 42 over 42, so it's like an 84 thing. This would be multiplied by 70 over 70, 30 over 30. Give me the 210, that's your common denominator. If you had to do fractions, which you don't always have to, but look at little mini lesson. Adding fractions. Haven't done that in a while, have you? All right, so 1, 2, 3, 4. 1 plus 2 plus 3 plus 4. No. See, this is a K and this is a C. They do not match up, but you still have to do it 4 times. So this is when K equals 1, when K equals 2, when K equals 3, and when K equals 4. Okay? So C plus C plus C plus C. How many you got? 4. Got to pay attention. All right. This one's a long one. You have to type in the 1 for both of these. So this is 1 minus 1 squared plus 1 minus 1 cubed. And then you do the same thing with 2, do the same thing with 3, and the same thing with 4. All right, you get 8 plus 28 plus 68 plus 134. You get, there you go, right there. 218. 238 is an answer. See it? Look at that. 15 problems down. 5 out of 36 slides down. Ooh, I say 36. Yeah, I said this is a long list. All right. Now we're going to go backwards. Write the sigma notation form. Got it? All right. So, way we're going to do this, fairly simple. What's my timer so far? We are going to figure out what the actual formula is. So, I equals, what's the first term used here? 1. So, I equals 1. What is the last number used here? The upper bounds. This is lower bounds, so we look under here, 2, 3, 4, dot, 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 5 to the 11th. 11 is my upper bounds. Now, what is the actual formula? Okay, what is the same in all of these? A 1 over 5, right? And then this would just be my I. So it's 1 over 5 times I. 1 over 5 times 1, 1 over 5 times 2, 1 over 5 times 11. You guys get it? Why do you guys attempt? Problem 17 through 21. You got them? Good. So, first thing, look at our lower bounds. Okay, 1 all the way to 14. Upper and lower bounds, right? Upper, lower. All right, what are we doing the same in here? We always have a 9 on top. We always have a 1 over here. So it's 9 over 1 plus I. Whoa, that was easy, wasn't it? All right, let's look over here. We look at the equation. Let's see, the only thing changing here is 1, 2, 6. So 1 and 6. All right, we got a 7 I over 6 plus 5. Look at this. You could do this already, right? Let's look, see what number changes. The number right here, you start at 1, you end at 4, right? So you have a 1 minus, okay, I over 4 squared. Sorry, quantity I over 4 squared. We good? All right, let's look at this one. We got 2 over n, 2 over n. Okay, we got 2n, 2n. Now this looks like we're just adding some n's. But there's nothing here. So since there's nothing there, I can assume that those are a 1. And our last number is a n. That's allowed. Okay, let's look. 2 over n minus 2 over n and 2 over n. So those are all the same. Now where is our I going to be? Right here you actually have to. 2i over n cubed, because when this is 1, it's just a 2. When this is 1, it's just a 2. Minus 2 over n. See? And I know most of you got that. All right, let's look here. The ones are the same. Well, once again, you got 2 over n to n over n. So there's going to be an I here, and we start with a 1, right? We're going to n minus 1, 2 over n. So 1 minus 2 I over n minus 1 quantity squared times 2 over n. You ever think you could turn this into this into that, and that into that? I don't think you did. But now you know you can, because it's pretty easy. All right. Basic rules. That pretty much concludes almost like a day of what we would have done in class. So now we're going to go over some basic rules. You don't want to write all that stuff out, do you? I wouldn't, because it takes forever and it's very annoying. So, here's some rules. When you have and we touched on this first one already, a summation with a k. K is just any type of constant in front of it. Like, for instance, like a 7. You could take that constant with all our other rules, you could push it to the front, okay? And you can just multiply your whole summation in the end. All right, very simple rule. So look right here. So when I do this rule, instead of doing 7 times 1, 7 times 2, 7 times 3, all the way up to 7 times 8, and I have my constant on here, what I could do is I'm going to bring my constant k in front of the summation symbol, like I said before. Right here, I'm going to bring that 7 up front. And now I'm just going to do this summation. So instead of doing 7 times everything and adding it, this is an easy one, isn't it? This is just 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And in the end, instead of doing 7 times all these and adding them together, I multiply the final sum by 7. So I add all these numbers together, and this is how I like to add. 8 plus 8 plus 8 plus 8 plus 4. Makes it easier for my head. It's 36. 7 times 36 is 252. Can you do 7 plus 14 plus 21 plus 28 plus 35 plus 42 plus 49 plus 56 and get the same answer? Of course you can. But why would you want to do all that when you can just do this? Right? Rule number 1 to save you a bunch of time. Rule number 2, the addition. This one, you don't really need to use. But what we're going to do in this case is, when you have the sum of 2 different things you're adding and they both have an I, you can take the sum of each one individually. Okay? So what this rule is, this is your addition and subtraction rule. And pretty much what it states is you're going to solve each function independently by itself, and then you're going to combine the answer in the end. Got it? So, treat this as 2 separate problems. I treat this as the sum, and once again I'm pulling my constant forward, of 13 from 1 to 10 of x, plus the sum of 1 to 10 of x squared. This is going to be useful very soon when I actually give you formulas to follow these sums too, and you don't have to write everything out. But right now, since you don't know those formulas and we had to write them out, this would be 13 times 1 plus 2 plus 3 all the way to 10. All right, that means 4, 5, 6, 7, 8, 9 to 10. Plus 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. You'd have to add all these together because we don't know the formulas yet, but we will know them in 20 minutes. You get 13 times 55. So this is 55 plus 358. And you would have gotten 715 plus 385, which is 1,100. Okay? It saves a lot of time. And the higher this number gets, the more you're going to want to know what these formulas are. All right? You got it? 2 basic rules. Now we're going to get into the rules that I was just talking about, the rules where you don't have to expand this stuff so much. Now, hopefully you remember the summation formulas. It has been shown to you in the past, and this is a very important thing, more also in like statistics, okay? So even if you're not taking a calculus class next year, you probably will be exposed to this on some level, all right? So the first thing is, say you're finding the summation of C. We did a problem like that before. C is as you said, a constant, all right? So what do you think the formula for that would be? If you said Cn, you're correct. You take the upper bound and you multiply it by the constant. So why don't you guys try problem number 1? Should have got 7 times 5, which is 35. So instead of doing 7 plus 7 plus 7 plus 7 plus 7, 7, you're doing it 5 times, so 7 times 5 is 35. Look at that, I already saved you time. See how much you, I'm sorry I didn't tell you that before, I know. Kind of mean, but I wanted to show you how it worked. This one, I. So if you have like an X or you have whatever this is, now notice I just put numbers down for some of these. All right, if you just have a number down and this is an X, you just assume that this is what X equals. If there's more than one variable, it's pretty much when you use your summation formula. So what do you think this is? You think it's IN? Nope. It's actually n plus 1 over 2. All right. What does that mean? Anytime you type this into this equation, you get the right answer instead of writing it out. So instead of this one being 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, you don't want to do that. You could just do, what's my upper bound here? 7 times 7 plus 1 over 2. 7 plus 1 is 8. So you got 7 times 8 divided by 2. 7 times 8 is 56 divided by 2, which is 28. So instead of doing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, right here. See? If this was a 6, 6 times 7 is 42 divided by 2 is 21. There you go, we just did a problem like that before. Good? Oh, my contacts are drying out, I'm sorry. Rule number 3. And you could go up much higher than cubes, but in this class we're just going to go to cube because they do take a lot of time to do. And if you understand the one concept of plugging stuff in, you understand it all. I squared is the most tricky. It is n times n plus 1 times 2n plus 1. So now you have to know your order of operations. So this is when you have an x squared. Remember, you're going to be splitting these things up and simplifying. So you're going from 1 to 4. So the 1, you always have to go from 1. If you go from 0 to 4, you can't use these formulas. These are only when you're starting at 1. All right, so you got 4 right there, right? What does that mean? Anyone? All right, so 4 plus 1, 2 times 4 plus 1. Now, 4 times 5, 2 times 4 is 8, 8 plus 1 is 9. 4, 5, 9. All right, 4 times 5 is 20, times 9 is 180 divided by 6, and you get 30 as an answer. So instead of doing 1 squared plus 2 squared plus 3 squared plus 4 squared, you plug it in here and you get 30, okay? Now you may say, oh, the other way is easier. Well, say I made this 100. All right, you want to do it that many times, where you can just do 100 times 101 times 201 divided by 6, and it spits out your answer right away. All right, last one. I cubed, you're going to do n squared times n plus 1 squared over 4. Okay, not that bad. And in this case, your upper bounds is 10. 10 squared times 10 plus 1 squared divided by 4. 10 plus 1 is 11. 10 squared plus 11 squared is 100 plus 121 divided by 4, which is 12,100 divided by 4, which is 3,025. All right? So that's how you use your summation formulas. Now what you're going to do is you're going to try a couple on your own. You ready? I want to try this using 2 different ends. All right? So this will give us a good idea of how it works and how the relationships are formed. So first thing you're going to do, you can use n equals 10. So what can I do to this equation? What matters here? I is the only thing that matters. Now, all you're going to do is, your first step is going to be to plug in your 10 for n. And we're going to just treat this as a normal problem. So this is actually two problems here. So you plug your 10 in right off the bat, right? So you're going to go from 1 to 10, and this is 10 squared. 10 squared is what? 100. So it's from 1 to 10 of I plus 1 over 100. So looking at our rules, you could do 1 plus 1 divided by 100, 2 plus 1, 3 plus 1, 4 plus 1, all the way to a 10 plus 1 divided by 100, or use all the rules we've been using. So, anyone have an idea what the first rule is? Split this up, right? Just as we did before. We could divide both things by the denominator. We can get 1 over 100 and actually just pull it out. Okay, you could do I over 100 plus 1 over 100, or, see this 100's right here? You could pull the whole 100 out first because it is a constant, right? Remember we said pull the constants forward? So you get 1 over 100 times I plus 1. This is pretty nice. Now that was rule 1. That was pull out all constants first. Rule 2 is to addition. We're going to treat these as two different problems, right? So now we get 1 over 100 times the sum from 1 to 10 of I plus the sum of 1 to 10 of 1. That's step 2. So you pull out your constants first, and then you separate all the plus and minuses. You make each one individual sums. All right, we got that so far? Hopefully. Now, the 1 over 100 stays out front. Do not lose it. Some people forget about it and just leave it away. Now, this is the I summation rule. The I summation rule states, as we said before, n times n plus 1 over 2, right? So our n here is 10 plus 10 plus 1 over 2, plus this formula right here is your c to the n. So we take the constant, which is 1, and multiply it by 10. All right? So this one into the I summation rule, this one into the C summation rule. Got it? Solve for each one of these individually. Leave the 1 over 100 out front. 10 times 11 is 110. Divided by 2 is 55. 10 times 1 is 10. 55 plus 10 is 65. 65 divided by 100 is, you can reduce it to 13 over 20 if you divide both by 5, or you could say 0.65. Easy. Do that problem, go. All right, so that problem is actually 1 to 100, I plus 1 over 100 squared. 100 squared is 10,000. I pulled it out front. So, if you didn't get that far, go again. All right, you want paused? Split it up as we did here. 1 over 10,000 from 1 to 100, I, 1 to 100, 1. Dump this into this equation. 100 times 100 plus 1 divided by 2. 100 times 1. 100 times 101 divided by 2 is 10,100 divided by 2 is 5,050 plus 100 divided by 10,000. 5150 divided by 10,000 gives you, we divide both by 5, 103 over 200, or 0.515. There you go. You get it? Not yet? We'll get it. We'll get it there. Let's do some more examples. Why don't you guys attempt problems 23 through 26? If you do not get it, we will go over it in 1 second. Let's keep. Let me sip of coffee real quick. First one, we have constant. So we take that 7 when we do. We use the constant rule. When you have a constant, you multiply it by the upper limit bounds. 7 times 12 is indeed 84. Got it? Constant. Constant times the upper bounds. Negative 216. You guys got that one at least? Problem 25. First step, pull the constant forward. 4 goes forward. All right, so we're going to use this rule right here. 4 comes forward. 4 times I from 1 to 24. So we're going to take 24 goes in for n. 24 plus 1 is 25 over 2. 24 times 25 divided by 2. If you want to do 12 times 25, that's okay. Or you can multiply the 2 divided by 2. 4 times 300. If you want to do it in one scoop here and get your 1200, you can as well. There you go. Look how easy that was. You did this problem in probably, I don't know, under a minute. Well, you didn't have to write out 4 times 1, 4 times 2, 4 times 3, all the way up to 4 times 24. This step problem, this has a couple steps. First step is you split them up. The sum of, pull the 5 forward, from 1 to 16, I, 1 to 16, 4. So the I, 16 is here, not our constant, but our 16, so it's 5 times 16 times 17 divided by 2, minus 4 times 16. 5 times 136 minus 4 times 16. This is 136. And you get 680 minus 64, which is 616. Boom! See how quick that was? Awesome. Let's go to the next one. Why don't you guys attempt these two? A little more difficult, but you should be okay. Alright, now, 27 probably tricked you. There is no rule like a product rule, quotient rule, stuff like that. This squared, you don't reduce this to I squared plus 1. You actually have to FOIL this. You have to expand it. This is I minus 1 times I minus 1. Tricked a couple of you, didn't it? FOIL. I squared minus I plus 1. So you have 2 minus I, so it's I squared minus 2I plus 1. And now you can get to work. You got it? This little square means expand it. So always do all the mathematics inside before you do anything else. So I'm going to sum 1, 2, 3. I have 3 sums here. Summation of I squared minus, pull the 2 forward, 2 summation of I plus summation of 1. And that's all upper limit boundaries of 20. First formula we're going to use is the I squared formula. Then we're going to use the I formula. Then we're going to use the C formula. We plug them into the equation. 20 times 21 plus 41 divided by 6. 20 times 1 plus 20. Subtract the numbers and get your answer. All right, now the formula for this one, I didn't write it down, is n plus 1, 2n plus 1, and this was n times n plus 1. This was divided by 2 and divided by 6. Right, problem 28. Split them up. You don't have to drag anything forward. I squared is n plus 1, 2n plus 1 divided by 6, and this is just cn. 2 times 11 times 21 divided by 6, 10. 385 minus 10, and as an answer you should get 375. All right, whoops, sorry. See, not too bad, is it? What do you guys attempt problems? 29 and 30. All right. Uh-oh. You're going to have to expand this first. FOIL it, right? We just FOILed it before, so we know what it is. Now, what's the next step here? We have to take the sign and do what? Distribute the I. So you get I cubed minus 2I squared plus I. All right? And now you split it up. Sum of I cubed minus 2 sum of I squared plus sum of I. And you're going to use your formulas, plugging in your upper limit boundary of 15. This is just plugging things in. This is n squared times n plus 1 squared over 4. N times n plus 1, 2n plus 1 divided by 6, plus n times n plus 1 divided by 2. All right? You get 1440, which is your I cubed, minus 2,480, which is your I squared, n plus 120, and gives you 12,040 as an answer. You guys get it? Awesome. What do you do for problem 30? And you sure I've done this one? Distribute I cubed plus I. Plug the 10 into I cubed. All right. So sorry, split it up. So you got n squared, n plus 1 squared over 4, n times n plus 1 over 2. 100, 121 over 4, 10, 11 over 2. 3,025 plus 55, and as an answer you get 3,080. I'm going to hold it right here. I think I'm holding it? No, point to it. All right. That's summation. By now you should understand it. And by now also we're going to crank it up a level. Ooh, this is the worst part. This is one of the most difficult concepts of the year. Just because there's a lot to it, but if you remembered everything and you put everything together, we are good. We're about halfway through the lesson. So approximate the area of a plane region from the right side. We're going to use 5 rectangles below to show that the approximation of the graph f of x equals x squared minus plus 5, and the x-axis between x equals 0 and x minus x equals 2. That says a lot of stuff. So here's what you need to know. This right here is the blue graph. So you want to find out what the area between this blue graph is and the x-axis. So, and this axis right down here, which is x-axis. Between 0 and 2. 2 is another name for 10 over 5. All right, I just split it up like this to show you in a second. Now we know that the area of a rectangle, I always call them triangles. Area of a rectangle is width times height, okay? So what we're going to have to do is, since we're splitting this up into 5 rectangles, when I divide 2 divided by 5, I get 1, 2, 3, 4, 5. I get 2 fifths, 4 fifths, 6 fifths, 8 fifths, and 10 fifths, right? So what is the width of my rectangles? You have the total length of x, which is, from 0 to 2 is 2, divided by the number of rectangles. So my total width here is 2, and my total rectangles is 5. That's how I get 2 fifths. That's how I get my 2 fifths, my 4 fifths, my 6. I just keep on adding 2 fifths to all these. All right? Step 1. So I want to find the area of each one of these rectangles. So now I got the width. So what I need to find next is I need to find the heights. So in order to find the heights of each one of these, what I have to do is what? I have to do something, right? Use a formula. And here's my formula. Area equals length. My width is going to be whatever f of x is, whatever these y values are when I'm at this 2 fifths. So, what do you think we do? I need to find this height. I need to find that height, and the way I found that is I take my I take my 2 fifths and I plug it into my original equation. Okay? So my x value plugged into my original equation gives me my f of x or my y value. So when I plug negative 2 fifths squared plus 5, well, I plug 2 fifths into this equation, I get 4.84. So the height of this rectangle here is 4.84. Find the height of this rectangle. What do you think I plug in? Not another 2 fifths, but 2 fifths plus 2 fifths, which is 4 fifths. So I take 4 fifths and I plug it into here. Negative 4 fifths squared plus 5. I get 4.36. So that's the height right here of this rectangle. Height of this rectangle. I take 6 fifths and I plug it in to the equation. Negative 6 over 5 squared plus 5 equals this. Now these are just these heights. These are the distances here, here, here on the y-axis. I take in 8 fifths and I plug it in. I get the height of this is 2.44. And then I take my 10 fifths or 2 and plug it in, and I get 1. So the height of this one's 1. So see, these are the heights. Height, 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 and height. Got it? Now, what am I highlighting here? All right. Now, if I want to find the area of each one of these rectangles, I could do width, which is 2.2 over 5, times the height. And the area of this is 1.936 units. Now this isn't 4 fifths. This is just another 2 fifths times the height, which is 4.36. And that is 1.744. 2 fifths times that number. You get 1.424. See, these are the actual widths, the areas of each rectangle. 2 fifths times 2.44 is 0.976. 2 fifths times 0.1 is 0.4. Now, how do I find the total area of all these things? I add them all together. So if I add all the rectangles together, I can get, hypothetically, the area under the curve, which is about 6.481. Obviously, it's a little less than the answer because there's spaces here. But the more rectangles we use, the more accurate our answer will become, okay? There's always going to be a little space, either a little bit too much or a little bit too low. So depending on if you're inscribing or circumscribing the rectangles, that's where your answer is. You have to use true integration to get pretty much the exact answer. You don't want to do that. See how annoying and long that took? If I wasn't plugging everything in for you, probably would have took you about 20 minutes to do that problem. There's an easier way. Easier way is using summation. So say we do the sum of 2 fifths, which is my width, right, times my height. Width times height. Okay? Width times height. It's always going to be 2/5, and this is my height. I can use the summation. Because now I can even use more rectangles if I want. I can crank this number up, and I won't have to do all this work. And I can get a more accurate answer. So, when I do this problem, summation of 2/5 from I to 5, right? We're just going to replace the x with a 5, minus 2/5 I squared plus 5. Now, what does that mean? Why did I get another thing like that? Well, we know in order to find the height, right? What I do is I take 2/5, which is my width, and I multiply it by I. So when the first one is 2/5. When my second one I'm going to add in here, 2 times 2/5 is 4/5. My third rectangle is 3 times 2/5 is 6/5. My fourth rectangle is 4 times 2/5 is 8/5. And my fifth rectangle is 5 times 2/5 is 10/5. That's why the 2/5 I squared goes in there. All right? And eventually you're going to get a better formula to use, but that's how this goes right now. So you have width is always 2/5, and then this is how we find our heights. Take the 2/5, you drag that forward, because it's a constant. 2 squared is 4, 5 squared is 25, I squared is I squared. You have to square each one. You do not square the negative sign because it's outside of this, so the negative stays negative, plus 5. You remember how to solve this now? We split it up, right? You have two pieces here. Negative 4 over 25, summation of I squared, summation of 5. And the first time is very difficult, but it gets easier. So you got 2/5 times I squared, you should remember, is n plus 1, 2n plus 1 over 6, and that's your 5. Cn, 5 times 6 times 11 divided by 6, plus 25. Multiply these, you get negative 8.8 plus 25 times 2/5. 16.2 times 2/5, and you get 6.48. Look at the answers. A lot less work. Pretty much the same answers. Got it? A little tough. This, I think, is a lot better than this. But it's up to you. If you want to waste all your time there. See, I cranked this up to 10 rectangles. You want to do this 10 times? Or you can just throw a 10 in here. And then just make this your 10s and 10s. All right? So this way is much better, much easier. That's using right side. So that's the right side of the rectangle. Now, say we didn't use the right sides to find heights. Say we use the left sides. Does that change anything, do you think? Now we're going to use the left side. Oop. Left side. So, when using left side, what we're going to do is use 5 rectangles as shown to find the approximation of the graph x squared plus 5. All right? So, area equals width times height. Got it? Total length of x times the number of rectangles. Same concept. Area equals width times height. All right? 2/5. Area is 2 over 5 times f of x, right? Same thing we did before. The only difference here is now these rectangles are circumscribed, meaning they go above the graph. All right? So when we find our f of x, we're using the left sides. So in this case right here, we use 0. 0 squared plus 5 is 5. So the height of that triangle is 5. Height of this one, just like before. Negative 2/5 squared plus 5 is 4.48. All right? Negative 4/5 squared, 4.62. Negative 6/5 squared. All right, and then finally negative 8/5. Notice we don't use this one right here because we're only using the left-hand sides of these rectangles. All right? So we have all the heights. Once again, what do we do with the heights? We multiply them by the width. What's our width here? 2 over 5. 2 over 5 times 5 is 2. 2 over 5 times 4.84, 1.936. 2 over 5 times 4.36, 1.744. 2 over 5 times 3.56 is 1.424. And 2 over 5 times 2.44 is 0.976. Add all these numbers together, and you get 8.08 as an answer. Now, really quick, this is 8.08. The other one was 6 point something. Why are they so different? Well, in this case, you have a little bit extra rectangle, so your answer is going to be a little bit higher. If you want to find the exact number, you can actually average the two, and it'd be very similar to what your exact number would be. It wouldn't be exactly, but it'd be a lot closer than both these together. People don't do that, though, because they just typically use straight-up integration to do this. So let's use summation. So when we use summation, from 1 to 5, length times width. Now, the width here is a little bit different. Notice this thing changes. All right? X squared plus 5. Now, x here is 2 times x minus 1 over 5. So what you're really doing here is you have your 2/5. Instead of being an I squared, it's I minus 1. Okay? Because you want this first one to be 0. So 1 minus 1 is 0. So this gives you your 5. When you go to your second triangle, 2 minus 1 is 1. So that gives you your 2/5. 3 minus 1 is 2. That gives you your 4/5. So the only thing that changes from left side to right side is, left side is I minus 1 when you plug it into the equation, and right side is I. All right, now everything else stays the same. This is a little more work because you have to do a little bit more algebra. So you pull out the 2/5. This right here becomes 2I minus 2, right? So another thing you could do here is 2 squared is 4, 5 squared is 5. I minus 1 squared is I squared minus 2I plus 1. So when I square this piece, I get this. When I square this, I get this. And when I square this, you have to square all 3 plus 5. You can't just pull out the 4 over 25. You actually have to distribute it into each problem. So you get 4 over 25 times this, times this, times this. Or you can just do negative 4 over 25 times all these summations. And then plus 5. So you're only going to multiply 4 over 25 times these 3 guys. And then you're going to summate the 5 separately. So you can't add the 1 plus the 5. It's too much work, too difficult. All right? So use all your formulas. 2 over 5 times negative 4 over 5 times n plus 1, 2n plus 1 divided by 6 minus 2, and n plus 1 divided by 2 plus cn, close parentheses, these are all going to get multiplied by that, plus cn. 2/5 times negative 4 over 25, 55, 35 plus 25. All right. 2/5 times negative 4 over 25 times 30 plus 25. Multiply these two. You get 2/5 times, all this stuff gives you 20.2. And as a final answer, you get 8.08. Look at that. Exactly the same. So you could do it either way. Notice all the shaded areas, all the extra. That's the difference between the two problems. All right? And what we did here was we just used some formulas. I don't know why that one popped up there. All right? You all good? Let's check out some more stuff. Now, we're going to go a little more advanced. We're about halfway through. What are you finding? What are you actually finding here? You're finding the what? You should say area under a curve. All right? Right here. How did you find it? The interval from A to B is divided into, how many subintervals do you think? N. N. Why N? Because it could be a different number each time. You remember what delta X was? That is B minus A, high end minus low end, divided by the number of subintervals. So that's how you find your delta X, okay? That's how you find what each width is. Now, we're going to change left and right into two things. One is going to be F, lowercase m, subinterval, or subscript I, all right? Now, your delta X is the width of each rectangle. You have two parts. You can either go low or you can go high. Now, f of lowercase m, sub interval I, is the minimum value. That's the lowest points the graph hits. All right, f big M is the maximum value. That's the high points of the graph. Now, obviously, you could have some going both, but in this case, low interval, mi, high interval, big M. All right, so that's your max and your min. Now, going over this, there are two types of rectangles, and we went over this back in chapter 2. So, first one, your inscribed rectangle. It lies inside the I subregion. So the area of inscribed rectangles. So inscribed means it's pretty much under the curve. The formula is you take the lower sum, the smaller number of the sum, s of n, lowercase sn, and that equals the sum from I equals 1 to n of f mi delta x. All right? mi is delta x times x minus 1. Remember how we went over that before? To write sum, you're using all the things pretty much on the left. Area of this is going to be actually less than the area of the whole region. Circumscribed is all the rectangles above. Okay? So they're the rectangles above the graph. Right? That lies outside the I subregion. Area is capital S of n equals n to m f of mi delta x. This one's a little easier because in this one your mi just equals delta xi. All right? So only difference between these two things is this when you add a negative 1. And this is the area that is going to be greater than the area of the region. Got it? Awesome. Now, finding the upper and lower limit sums. So going over this, it's actually not that bad. We are going to find the upper and lower limit sums for a bunch of stuff right here. Okay? Now, the way this works is fairly simple. In the graph, f of x equals x squared, and the x-axis is between 0 and 2. Alright? Sorry, just need to charge here real quick. So, first thing I want you guys to do is find delta x. So, go get delta x. Alright, you should find delta x to be b minus a, 2 minus 0 over n, subinterval. So, where are we at? You have x is the lower limit sum, the graph is the upper limit sum. You're going from 0 to 2, right? I know I'm not on the screen, but close enough. So, 2 minus 0 over n. We don't actually know what n is because I didn't tell you how many triangles yet. This is more hypothetical. But, so you get 2 over n. And you can choose many different n's if you want later on. In this case, though, we're going to stick with what we got. Let's see if this works. Next thing you do, you have to find mi. Whoops. That is delta x times I minus 1. Now, I minus 1 stays I minus 1 always. All right? X minus 1, the only thing that changes is the delta. Oh, we're good now. All right, so 2 over n, which you just found, times I minus 1. Sorry, I just had to put a charger on my phone. Take our delta x that we found first, and we put it in front. And then we pretty much distribute it. 2i minus 1 over n. Right? 2 times I is 2i, 2 times negative 1 is minus 2 over n. Now we're set and ready to go. So our s of n equals that f of this times this. F is our function, so it's x squared, right? So instead of x squared, it's 2 minus 2 over n squared times delta x, which we found before to be 2 over n. Like I said, it gets easier. When you square this, 2i minus 2 squared. So you have to pretty much FOIL this. 2i minus 2 times 2i minus 2 is 4i squared minus 4i, which gives you your negative 8i, plus 4, over n squared. So FOIL squared times 2 over n. Now, you want to distribute the 2 and the n in there. Makes things easier. 2 times 4 is 8, negative 16, 8, and then n times n cubed, 1 plus 2 is 3. All right? Got it? Don't worry, we're going to be given n's numbers in a moment. Anyone know the next step? Next step is you're going to pull out, is there any constants here we can pull out? Oh, we can divide all these by 8, right? So this becomes I squared, this becomes negative 2i, and this becomes 1. And we can also pull out an n cubed because n is technically a constant. So the 8 comes out, and the n cubed comes out front. And now we're just going from 1 to n. Now n could be any number, so when you do this, you don't actually plug in numbers, you're just using your formulas, which is nice. The I squared formula. So n over n plus 1, n over, from 1 to n of I squared minus 2 from 1 to n of I plus 1 to n of 1. So we're going to use our 3 summation formulas to solve for this. And we pulled out our 8 over n cubed. So when we do that, 8 over n cubed, summation formula for x squared, summation formula for x, and summation formula for a constant. Now watch what happens. If n was like 10, I could just plug 10 in here, and it'd spit out an answer. Now say I want to use 20 rectangles. I can plug 20 in here. Let's spit out an answer. Say you want to use 100 rectangles. I plug 100 in. Spit out answers. All right? So say it was just 5 rectangles. I didn't say it was 5, but now I'm just throwing it out there. Maybe it was 5 rectangles. What would I plug in for n? 5. It'd just be 8 over 5 cubed, which is 125, times 5 times 6 times 11 over 6, minus 5 times 6. Oop, that should be a plus. Mess it up. Plus 5, and you get 1.96, right? That's a plus. See? If I increase the number of rectangles, it increases the accuracy of the answer. So just think of this answer right here, 1.96, and we're going to do this with the upper limit sums. So that's the lowest. It's going to be about 2, all right? So that's the lowest possible number you're going to get. Now we're going to change the endpoints, and this makes it actually easier. The endpoint from this one is just delta xi. So once again, do the same exact first step. Delta x equals b minus a. So we're going between the x-axis and there. Our b is 0. Our a is 0. Our b is 2. 2 minus 0 divided by the number of rectangles, which we don't know yet. It could be anything, which is 2 over n. To find the endpoint, it's delta x times I. So it's just 2 over n times I, which is 2i over n. That was easier, wasn't it? Less work. All right, so we're going to take our endpoint, and now we're going to use our upper limit sum, which is f big Mi. So when we use this, f big Mi, we're going to take our function, which is x squared, and we're going to plug in 2i over n squared into it. Now this is why I like this one better. 2i squared is 4i squared over n squared. Whoop. Why never you write that? Whatever. 4i squared over n squared times 2 over n, right? 2 times 4 is 8i squared over n cubed. Got it? Pull out the 8, pull out the n cubed out front. Summation of I squared is n plus 1, 2n plus 1 plus 1 over 6. All right? If there's 5 rectangles. So this is your answer right here. What do we do? Oh, sorry. Went too quick. If you want to multiply the 8 in here and the n cubed in here, you can. 8 divided by 6, take 2 out, you get 4, n plus 1, 2n plus 1, 3n plus 1. That's just simplest form. You can leave it like this too, though. This, or this. All 3 are correct. I forgot. Last year's class liked this way the best. So if n equals 5, I jumped the gun a little bit. You can just plug a 5 in there, and it will spit out your answer, which gives you 3.52. So notice the one was about 1.96, I think. This is 3.52. There's a big difference between the two, and the only reason for that is because you're using only 5 rectangles. Say I use 100 rectangles, I can get a much more accurate answer. And I bet the answer would be somewhere around like 2.73, maybe. Try it. Try it with 1,000 rectangles, whatever. Good. All right, let's move on to, you want to try 2? You do? Good. Try 35 and 36, the minimum and maximum. Ooh, just hit an hour. And we're almost done. No, we're not. All right, so minimum. So first thing, delta x is 2 minus 0 over 4, which is 1/2. Got it? M of I. Delta x times I minus 1. All right, so 1/2 times I minus 1 is 1/2 I minus 1 over 2, or 1/2 I minus 1/2, or you can just leave it like this. Okay, step 2. Take this, plug it into your f. My f here is 2x plus 5, right? So I'm going to do 2 times 1/2 I minus 1 plus 5 times delta x, which is 1/2. All right, so pretty much this whole thing goes in for the x here. 2 times that plus 5. What's half of 2? Ooh, that was my name. Half of 2 is 1. So you're left with, these cancel out, I minus 1 plus 5 times my x, which is 1/2. Is there any constants here I could drive forward? The 1/2. The 1/2 goes in front of the thing. But first, oh, look at this. What's 5 minus 1? 4. You can do it either order. Drag the 1/2 out front. 1/2, and then you sum each one. The sum of I, the sum of 4. We're going to use these formulas right here, right? 4 plus 1 over 2. 4 times 4. Half of 10 plus 16. Half of 26, which is 13. You got it? Awesome, 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 awesome. Minimum, maximum. Show you how they're different. Delta x here. Delta x is always the same. Still 1/2. Only difference is this part. Delta x times I. So 1/2 I. I like it. S of n. So big S of n equals from 1 to 4. 2. We're going to take this 1/2 I and we're going to plug it into the x. So 2 times 1/2 I plus 5. 2 1/2 I plus 5 times 1/2. 2 times 1/2 is just I plus 5 times 1/2. So take this 1/2. We could drag that straight forward. Sum of I, sum from 1 to 4 of 5. 4 plus 1 over 2. 4 times 5. 10 plus 20, half of it. Half of 30 is 15. Notice the numbers are a little bit different. The actual answer is probably around 14. See how easy that was? That was 2 problems. Good. Hopefully. Go to number 37. Why don't you guys try this one real quick? And now we're just going to do a bunch of these problems and see how you do. Delta x. 3 minus 0 divided by 6. 1/2. 3 over 6 is 1/2. Little ma. Minimum 1/2 times x, or I minus 1, equals I minus 1 over 2. If you want it, like I said, you can put in any form you want. Now, you're going to take this I minus 1 over 2, and you're going to plug it in for both of these x's. Right, because that's the formula. And then you're going to multiply it by 1/2. So you got 1/2 times 2 times I minus 1 over 2 quantity squared minus I minus 1 over 2 plus 5. You have to FOIL the top, and the bottom becomes 4. So it's 2 times I squared minus 2I plus 1 over 2 squared, which is 4, minus I minus 1 over 2 plus 5 times 1/2. 2 divided by 4, so this bottom number here becomes a 2. I'm going to pull this 1/2 forward. You can always just pull your delta x forward right away. I don't even know why they put it in here. 1/2 I squared minus 2I plus 1 over 2, because I did 2 divided by 4 by 2 down here. This stays the same. All right. Now, how do I get from here to here? Well, since these are both over 2, watch what I could do. I could take these forms right here, just the greens, and combine them. I squared stays, negative 2i stays, 1 minus 1, 1 minus 1 is 0, right? So, oops, sorry, I squared, negative 2i plus I is your, sorry, negative 2i, I'm really hacking this up, negative 2i minus I, negative 3i, 1 minus a negative 1 is 1 plus 1, which is 2. And it's still all over 2, and then you're adding 5. Got it? So now I'm going to take a problem out of a problem. I have the 1/2 pulled down in front of everything, and I take the 1/2 and I can pull it out of these 3 summations. All right, so if I divide each one of these by 2, I get 1/2 out front, I squared over 2, negative 3i over 2, and then 2 over 2 is what? 1. 1 plus 5 is 6. So if you want to simplify it that way, you can. There's other ways to go about it, and you'll end up with the same answer. But what I did 2 by 2 is 1. 1 plus 5 is 6. I just divided all these by 3. So now you have your 1/2 out front, and now you're going to take a 1/2, put it out front of the summation here. 3 over 2, negative, put it out in front of this summation, I, and the 6 stays. All right, so now you're going to use your 3 summation formulas. Having fun yet? Which are I squared I and C. So the I squared one, 6 plus 1, 2 times 6 plus 1 over 6, minus 3/2, 6 plus 1, plus 6 times 6. Calculator work. 45.5, negative 31.5, 36. You have to take half. Don't forget about this half we did at the beginning. So add these all together and subtract them, and then divide by 2. So this becomes a 50 divided by 2 gives you 25 as an answer. We all good? Thumbs up, thumbs down. What do you got? Thumbs up. All right, why don't you guys try 38? It is the same problem, and now we're doing maximum. All right, we got our maximum going on here. The delta x is the same. 3 minus 0 divided by 6 is 1/2. Big MI, delta xi. So, 1/2 times I, or I over 2. Whatever way you prefer to write it is 100% okay. The formula, capital S of n equals. So the only difference is you're using your f of mi. So we take our formula right here, and we're going to plug in I over 2 in for each x, and then multiply it by 1/2. So 2 times I over 2 squared minus I over 2 plus 5 times 1/2. I squared over 4, only difference. 2 times 4, or 2 divided by 4 is 1/2. So I squared over 2 minus I over 2 plus 5, see the 1/2. What do I do with my 1/2? Drag it to the forward, drag it to the front. All right. So this is 1/2 I squared, negative 1/2 I, and this is just 5. Once again, I'm going to use my 3 formulas. 6 plus 1, 2 times 6 plus 1, 6 plus 1 divided by 2, and 6 times 5. 1/2 of this stuff added together. 1/2 of 65, which gives you 32.5. Now the only difference here really is that number. Got it? How are we doing, all right? All right, why don't you guys try problem number 29, the minimum. Delta x, 3 minus 0 over 5. 3 minus 0 divided by 5. B minus A over number of rectangles, 3/5. Little mi, 3/5 times I minus 1. So, you're going to do, plug it in here. So you're going to cube this. 3/5 I minus 1 cubed times 3/5. You know how to cube things? Multiply by itself 3 times. When you cube this, you get I cubed minus 3i squared plus 3i minus 1. I minus 1 times I minus 1 times I minus 1. 3 cubed, 3 times 3 is 9, times 3 is 27, 5 times 5 is 25, times 5 is 125. Okay, this was just I minus 1 times I minus 1 times I minus 1. So you get I squared minus 2I plus 1 times I minus 1. It spits out this. Times 3/5. 3 times that is 25. This times this is 625. Oh wait, 3 times that is 81. Sorry. Duh. And you pull that in front of the thing, and then you separate these all. So you get 81 over 625, I cubed, minus 3 delta, or sigma I squared plus 3 sigma I minus sigma 1. All right, go look back in your notes to see how to do this. You should have. Those are your formulas that you're going to need. 8 over 625. So you, the I cubed one, which I cubed right here. What are we using? 5. 5 squared. 5 plus 1 squared over 4. 5, 6. 5 plus 1. 2 times 5 plus 1 divided by 6. 5 plus 1 divided by 2. And then 1 times 5. 81 over 225 minus 165 plus 45 plus 5 minus 5. 81 over 625 times. This actually equals 100. 12.96. Boom. We good? How are we doing here? Hopefully brains aren't crashing on me. Next problem, let's do the maximum. All right. 3 minus 0 over 5, 3/5 still. Delta x is 3/5 times I, which is 3i over 5. You're going to take your 3i over 5 and you're going to cube it. Once again, maximum a lot easier than minimum. 3 5 cubed times 3 5. 3i cubed. 3 times 3 times 3, we said before, is 27. I cubed over 125. 81 I cubed over 625. You pull the 81 over 625. Throw it. Take it. Just move it in front of that sigma. Use your I cubed formula, which is n squared plus n plus 1 times n plus 1 squared over 4. 81 over 625 times 900 over 4. 81 over 625 times 225, and you get 729.25 or 29.16 as an answer. All right. We all good? Hopefully. Getting the hang of it? No, not yet. All right, we'll do 2 more. Try to find the minimum area of problem 41. All right, so delta x. 1 minus 0 over 3 is indeed 1/3. Mi. 1/3 times I minus 1. 41 is actually easy. You're going to plug it in there, multiplied by delta x. So negative 4 times 1/3 I minus 1 plus 5 times 1/3. Negative 4/3. All right? Negative 4 divided by 3 is negative 4/3. I minus 1 plus 5 times 1/3. Now, negative 4/3 I minus and a minus is plus 4/3, right? Plus 5 stays plus 5, right? Because you're not distributing this in there. Times 1/3. All right? I can pull the 1/3 forward. Negative 4/3 I plus 6 1/3. 5 plus 4/3 is 19 over 3 or 6 1/3. It doesn't matter. They're 2 numbers. There's no variables attached. You just combine them. And now you do your summation. You're going to sum up. Pull out the negative 4/3 forward. You don't have to pull out anything forward. See? Same thing. Doesn't matter how you write it. So 1/3 times negative 4/3 n plus 1 divided by 2 plus c times n. 1/3 negative 4/3 times 6. 12 divided by 2 is 6. 19/3 times 3 is 19. 1/3 negative 8 plus 19. All right. Oh, there's my formulas right there. Came a little late. 1/3 times 11, which gives you 11/3. All right. You good? Minimum area. Okay, so we're going to do next. Or 3.67. We did minimum. Let's shoot up a maximum. Different type problem though. We're going to just shoot around now. 9 rectangles. So from 0 to 1, 1 minus 0 over 9 is 1/9. Maximum delta x, which is 1/9 times I, or I over 9. You're going to plug it into this equation right here. Whew. Getting tired yet? I over 9 squared plus 2 times your delta x, which is 1/9. I squared over 81 plus 2 times 1/9. Take the 1/9, pull the 1/9 forward. I squared over 81 plus 2. You're going to split these up. So you got 1/9, 1 over 81 from 1 to 9 of I squared plus from 1 to 9, 2. You're going to use your two formulas right here. So we got 9 plus 1, 2 times 9 plus 1 divided by 6. 9 times 2, which is that times that. 3.52 plus 18 divided by 9. 1/9 times 21.52, and you get 2.39 as an answer. Boom. Starting to get the hang of this, right? Told you would. Another one. Just keep on busting these out. We're going to do as many of these as it takes till you guys become experts. So, delta x. 5 minus 2 divided by 6. Once again, you get a 3/6. All right. So, mi. 1/2. I minus 1. Got it? All right. That's not too hard. We're going to plug it in for the x. So, 3 times 1/2. I minus 1. Minus 2 times, my 1/2 didn't pop up, times 1/2. All right? 3 divided by 1/2 is 3/2. I minus 1 minus 2 times 1/2. Distribute, there we go. Distribute 3/2, 3/2 I, minus 3/2, so minus 2 times 1/2. Negative 3/2 minus 2 is negative 1/2, minus 2 is negative 3/2, or negative 7/2. So you get 1/2, you're going to drag them out front, 3/2 I minus 7/2. Split that. 3 times. I could divide. You don't have to do this if you don't want. See how they're both divided by 2? I could pull out that 2. 2 times 2 is 4. Just trying to show you a different way to do this. So I get 3i minus 7, and I pull out the half, and that's a 1/4. 1/2 times 1/2 is 1/4. I'm going to use my formulas. 3 times the quantity. 6 plus 1 divided by 2, minus 6 times 7. 1/4 of 63 minus 42. 1/4 of 21, which gives you 21 over 4. Or, what do you think? 5.2? 5. Bam. We all good? Awesome, awesome, awesome. Awesome, awesome, awesome. All right. You want to take a break? Of course you don't. You want to do a different theorem. So, we're going to pop on a new theorem here, and then we're going to do a couple of these answers, and then crack my knee again, and then we'll be done. So let f be continuous and non-negative on the interval from a to b. The limits as n approaches infinity are both the lower and upper limit sums that exist are equal to each other. Ready to see how to do this good? The limit of s of n as n approaches infinity equals the summation, we said, f of little mi delta x, which also we want to have equal f of big Mi delta m and equal s of n. So what we want to do is we want to try to get the lower limit and the upper limit sum equal to each other. All right? Where delta x and these things are the minimum and maximum at the same time of the subinterval. Okay? Seems like a lot of work, right? It's really not that hard. So what you have to do is you have to go over the definition of the area in the region of the plane. F is continuous and non-negative on the interval from A to B. The area of the region bounded by the graph of F and the x-axis and the vertical lines A, x is A, and x of B is. So pretty much what you're doing is you're bounded by lower and upper limits, right? So the area from 1 to n is f of ci delta x. Notice it's not an m, bigger or lowercase m, upper or lowercase m, it's now a ci. Now ci is between x subinterval I minus 1 and x subinterval I. So this is between the minimum and the maximum value. Okay? That's pretty much the middle piece. So this is the minimum, this is the maximum. You're finding the middle of the rectangle, and you're going to do it that way. So you don't have as much. So you have a little bit above, you have a little bit below, and hopefully they cancel each other out. You still have delta x being b minus a over n. We're going to start that the same. But now delta x is going to be xi minus xi1. So it's the difference between these. So what this formula actually does, and your CI, your actual CI here is a plus delta xi. So it's your original formula plus whatever the change in x is, plus whatever times whatever interval it is. Now, what that means is you can have different sized rectangles too. So this thing's going to get crazy. You ready? It's going to be bananas. Cray cray, whatever you want to call it. You ready? If you thought before was tough, this one's whoa. All right, so 44. The area of the region bounded by the graph of x cubed, and the x-axis vertical line is x equals 0 and x equals 1. So we have our graph here. We have our intervals, x equals 0, x equals 1. So we want to know what that graph is. So the first thing is delta x equals 1 minus 0 divided by however many triangles or rectangles we have. We don't have a number anymore. Now they're just going to be n's because we don't know how many. And that's 1 over n. All right, we good? All right, CI equals delta x times I. So it's 1 over n times I, which is I over n. Okay, still good? All right, so the area equals the limit of n, I equals 1, f of CI, delta x. So it's the limit as n approaches infinity, because there's an infinite number of rectangles now. That'll give us almost an exact answer. The rectangles are like a sliver. All right, so we type this in, x over n cubed times 1 over n, right? I over n cubed. I cubed over n cubed times 1 over n. I cubed over n to the 4th. Now, I is not a number, n is just a number, right? So we can pull the n to the 4th out front. So limit of n approaches infinity of 1 over n to the 4th times this. Now, we're going to use our I cubed formula. Our I cubed formula is n times n plus 1 squared over 4. All right? So now I'm going to actually set you up with a different number of formulas because you want to expand all these formulas. And if you have them all expanded right off the bat, it's easier. N plus 1 squared is n squared plus 2n plus 1 times n cubed. This becomes n to the 4th plus 2n squared plus n squared over 4n to the 4th. Because what I did was I took this 1 over n to the 4th and I multiplied it back in. Now what rule do you boys and girls need to use when n approaches infinity? And limit behavior. Give you a hint because of an L. If you said L'Hopital's rule, you are correct. So we pick the highest degree numerator and the highest degree denominator, and we negate the rest. So in this case right here, you have n to the 4th divided by 4n to the 4th. You pretty much are dividing everything by n to the 4ths, right? What happens to these two? These cancel out, right? Leaving you with 1/4. This one cancels out, leaving you with 1n on bottom and 2. Cancels out, leaving you with 2 n's on bottom and a 4. What happens when I plug infinity in here? You get 1 over infinity equals 0, remember, right? So you get 1/4 plus 0 plus 0, and your answer is 1/4. If you use L'Hopital's rule, n to the 4th over 4n to the 4th, cancel them out, you would have got 1/4 as well. And there's your answer. I think it's much easier once you get the hang of it. All right, so we can do 2 more problems, and it'll be good. All right, so problem 45. Find the area of the region bounded by the graph. We're going to use the same rule again. All right? I'll walk you through it if you're having trouble. Delta x, 2 minus 1 divided by n. We don't have a number of graphs this time because it's an infinite number of graphs. 1 over n. CI, as we said before, is a plus I delta x. Our a in this case now is 1. So now it gets a little more difficult. It's 1 plus I, 1 over n. All right? So it's a plus I over n, which is 1 plus I over n. Got it? So that's our CI. So we're going to use our formula. The area formula is limit of n approaches infinity from 1 to n, f of CI. So we're going to take this and we plug it right now into there. So it's 4 minus 1 plus I over n quantity squared times 1 over n. When we square this, you get 1 plus 2i over n plus I squared over n squared. You just FOIL it. 4 minus 1 is a 3. This becomes negative, this becomes negative, because I have to distribute the negatives over 1 over n. Alright? Now in this case, I can pull the whole 1 over n forward. Okay? Or I could take the 1 over n and multiply each problem number. It doesn't matter what you do till the end. If you keep it in or take it out, it's up to you. I'm going to show you right now, if I don't pull up front and I multiply it through all of them, how it changes. Okay? Like I said, 3 different ways to get the same answer. Did I say that? Maybe I said that. Alright, so we don't care about the n's, we care about the i's. So we're going to sum each one of these. So it's 1 over n times the sum of 3, 2 over n squared, sum of I, 1 over n cubed, sum of I squared. So we're going to use our definitions. 1 over n times 3n, 2 over n squared, n plus 1 over 2, 1 over n cubed, n plus 1, 2n plus 1 over 6, right? And now you're going to expand. Okay? This becomes 3n over n. This becomes 2 times, this is n squared plus n over n squared times 2. This right here becomes, when we expanded this before, we got 2n cubed. So this is 2n squared plus 3n plus 1 times n. And this is what you get here. Expand a little bit more. Distribute the 2's, or you can just cancel out the 2's. If I distribute them, you get 2n squared plus 2n over 2n squared. Distribute the n cubed here. Alright? If you want to just reduce everything, you can. I would use L'Hopital's rule. 3n, so you get a 3 here. Alright? 2n divided by 2n is 1. This is 1 over n, so that's going to go away anyway. 2n cubed over 6n cubed is 1/3, and you know these guys are going to go over way anyway. Right? So it's, wait, what did I do here? Alright, so you got 3, minus 1 is 2, minus 1/2 is 5 over 3. If you want to combine these things, you can. Like I said before, I would just dump them all to 0, because you never even need them. Because as you approach infinity, your answers are going to be 0 anyway, and your answer is 5/3. Alright? Seems confusing? Not confusing. It's confusing because there's different ways to do it. Alright, why don't you try 46? 5 minutes? No? Alright, this will be the last one. Alright, so delta x, 3 minus 0, 3 over n, ci is a, which is 0 here, plus delta xi, so it's just delta x times I, which is 3i over n. Right? What you do here is you're going to square 3i over n and add 1 and then multiply by delta x. 9i squared or n squared plus 1 times 3. Alright, what you do next is what? Take the 3, pull it forward. Alright, or you could take 3, distribute it. I wouldn't actually pull anything forward here because it's actually easier to do in the end without it. So 27i squared plus 3. Summate them both. Take the 27n cubed out. Take the n out. So 27 over n cubed, n plus 1, 2n plus 1 over 6, 1 over... Now you should know what these things are by now, and you can actually just plug in what they are right away. So you get 27 over n cubed, 2n cubed, plus 3n squared plus n over 6, plus 3n over n. Distribute the 27 in, distribute the n cubed in. Alright, you don't need these. L'Hopital's rule, you can just use the highest terms, 54 and 6. If you want to put them in just to see how it works, you can. 9 plus 3 is all that really matters, which is 12. Alright, you guys got these? They're so easy, aren't they? 47, go. First thing you should do, delta x, 4 minus 1 over n. Right here, 3 over n. 4 minus 1 is 3. Divided by n is n. Ci is a. Your a here is different. It's not a 0, so your a kind of changes sometimes. It's a 1. 1 plus 3 over n times I. 1 plus 3i over n. All right? So, you're going to take that Ci. You're going to plug it into that equation. So it's 25 minus 1 plus 3i over n squared times delta x. All right? I shouldn't have to go over how to square these things anymore. 25 minus 1 plus 6i over n plus 9i squared over n squared times 3 over n. All right? When you do this next problem, what you're going to do is 25 minus 1 is indeed 24. Minus, because you distribute the negative sign. All right, then you're going to take the 3, multiply each one of these numbers by 3, and put an n here, n squared, n cubed, okay? You're going to summate these. So take out a 1 over n, take out an 18 over n squared, and take out a 27 over n cubed. You're going to throw your problems in. 1 times n squared plus 2, and once again, I just expanded that right away. Multiplied by 72 by 18, so you're just pretty much reducing here. You're going to use your L'Hopital's rule. Okay, when you use that, you keep your 72, you keep your 9, and you keep your minus 9. So 72 minus 9 minus 9. 72 minus 18 is 54. Once again, these all go to 0, because as you approach infinity and it's on bottom, it goes to 0. All right? Awesome. Problem 48. First thing you do is you're going to find delta x, which is negative 2, minus a negative 2, which is 4. 4 over n. So your a here is negative 2, so it's negative 2 minus I times 4 divided by n. Negative 2 plus 4i over n. You're going to take this once again and plug it in for the x squared. So 4 minus a negative 2 plus 4 over n squared times 4 over n. Now, you're going to FOIL this part right here. 4 minus, distribute to 4. 4 minus 4 is 0. This becomes a positive, this becomes a negative. Okay? What I did here was, left the negative out front. 4 over n. So you're going to take your 4, multiply here, and multiply both these by n. Alright, negative, distributed afterwards. This becomes positive, this becomes negative. You're going to pull out your 64 over n squared and your 64 over n cubed. Alright? Expand, expand. Distribute the 64 and n squared, distribute the 64 and n cubed. You're going to use your L'Hopital's rule if you like. Or you can keep on expanding everything. Key here is 64 n squared, 2n squared is 32, minus 128 over 6, which is the same as 64 over 3. So these are the only two numbers that matter, because everything else becomes 0. 32 minus 64 over 3 is 32 over 3, or 10.67. Good. This one right here, delta x, 3 minus 1 over 2, 2 over n. A is 1. 1 plus 2 times I over n, 1 plus 2i over n. All right? Plug it in for a cube. Now, when you cube this, you end up with 27 minus, well, if I square it, I get this, times this, so I'm just expanding it slowly. And then I FOIL that back in there. 27 minus that stuff. So all you do really is 27 minus 1, you get 26. Distribute the negative sign. Take this, multiply the tops by 2, the bottoms by n's. You expand it. All right, shouldn't need to explain this anymore, you should know it. After you expand it, what you do here is you're going to take your things in front, multiply them in, use your L'Hopital's rule, this becomes 52. You care about this one, which is 6. You only care about the front ones, which is 8. And you only care about these, which is 4. 52 minus 6 minus 8 minus 4 gives you 34. All right, and our last problem of the day. We're going to go through this one as quick as possible. 1 minus 0 over n is 1 over n. C is 0. 1, because that's our 0. 1 over n times that, so it's just I over n. So it's not too difficult. You plug it in for both x's. 2 times I over n minus I over n cubed. So it's 2I over n, I cubed over n cubed times 1 over n. Distribute the n to both of these. Seems a lot more difficult than it is. 2I over n, I cubed over n to the 4th. Like I'm doing this fast. Take out the n squared, 2 over n squared. Take out the n to the 4th. Expand, expand. Distribute the 2 in, distribute the n squared in. There you go. So all you care about is this, which becomes 1, and this, which becomes minus the 4th. The rest go to 0. So 1 plus 0 is 1 minus 1/4, which gives you 3/4. So right there is the entire lesson. All right, no, it went a little quick at the end, but you guys should have been pausing playing. And by now you guys should be great at this stuff, and hopefully you do well on the next test. And that concludes our area portion of integration.